So we have two formulas we learn, and we want to do the proof, and let's pick one to prove. Assume that we have the function f of x equal to sine of x. So we want to find the derivative of sine of x. So by definition, we have the derivative is the limit of f of x plus h minus f of x divided by h when h approaches to 0. And then the next step, we plug this in. So from here, this is the trigonometry identity. So we apply the trigonometry identity for here. Okay, and then we copy down the side of x. And then I combine for this step. I combine this one and this one. Okay, next to each other. I move them next to each other. And then I separate this plus. So I have the one in the below. Then I factor out the side of x. So I got this. So you notice that we have a plus sign in the between. So the limit of the sum is the sum of the limit. And also we have a multiply in between the function. So we can separate them with the multiplication. So we have the we have the step below. Okay, so side of x, the limit is h approach to 0. So this function has no h. So this is like a constant. With the axis will be the constant. So h approach to 0, the answer is side of x. The next one, we don't know the answer. So I'm just leave it here and then I go down and prove this. Okay, so we're gonna look at that for later. Similarly, for the cosine of x, when h approaches to 0, the cosine of x does not have h, so the answer would be the cosine of x. And we learn from section 1.5, problem number 3, when we try to guess the limit, of sine of theta divided by theta as theta approach to 0. In that example, we guess that the answer's approaches to 1. So we write down 1 in here for this using section 1.5 example 3. Okay, so we all have this we all have the answer except for the orange. The limit of cosine of h minus 1 divided by h as h approach to 0. So the orange part that we have is right here. So what do? Is I multiply by the conjugate of the cosine of h minus 1. Then we got the top cosine square of h minus 1, and the bottom we multiply them together. And we got sine square of h, because we learned from identity that cosine square of u plus sine square of u equal to 1, right? So if we have cosine square of u minus 1 is equal to negative sine square of u. Okay, and we separate the sine square of u is like sine of h and sine of h. Sine square of h is sine of h times sine of h. So it's multiplied, so we separate them. We separate the multiply for the top, and the bottom we separate the h and the cosine h plus 1. So we see this again, right? So what is this one? This is example 1.5, example 3. So you can move the minus out, and that will look exactly like example number 3 in section 1.5. The answer is 1, and we have the minus in the front, so the answer is negative 1. And for this, what all we need to do is just plug in the 0 for the h into this function. The side of 0 is 0 on the top. Cosine of 0 is 1 plus 1. So it's give us negative 1 times 0, so the answer is 0. So go back to the proof. So we got 0 right here, right? Okay. So side of x times 0 from this step. So this is gone. So we're left with cosine of x times 1. So the answer is cosine of x. So from the beginning, we have the function f of x, and we use the definition of the derivative, and we can prove that the side of x derivative is equal to the cosine of x. You will do similarly proof for cosine of x derivative will equal to negative sine of x.